Good morning, good afternoon, and good evening for Mr. Danar and all of the audience. So we are from group 9. We will present about experimental population of rice weevil or Cytopilus oryzae in response to amount of it. So first, let me introduce our team members. The first one is Gerinda Resti with student number 218. And then Hana Tsalisa with student number 219, and me, Gabriel Stella with student number 226. First of all, what is rice weevil? So rice weevil or Cytopilus oryzae are a type of beetle that occur mainly in the tropic. Rice weevil are small size, about 2 up to 3 millimeters, and are most commonly found in rice. They can be also found in other storage grain products such as corn, millet, wheat, sorghum, oats, and barley. Rice weevil, whether in larval or adult stage, are not harmful to human beings as they are not known to spread any disease or infection or bite people. So why are rice weevil found in rice? Rice weevil can be found in crops in the field before they are harvested and brought to a food processing facility. Rice weevil may only be visible in food products sometime later and generally enter homes when these products are purchased by consumers. The presence of weevil can be identified through signs such as round holes in the kernels of rice grains and increased moisture level where grains may feel them. And then we talk about rice weevil life cycle. The life cycle of the rice weevil is 30 up to 45 days under optimum condition, namely at 29 degrees Celsius, 14% grain moisture content, and 70% humidity. Live quite a long time without the food for about 36 days, according to Stepu et al. On 2004. The egg development period of Cytopilus oryzae is more or less 5 until 7 days. The larval stage of Cytopilus oryzae lasts for more or less 21 up to 27 days. The pupal stage lasts for more or less 7 days. And then how the attack symptoms of rice weevil. Cytopilus oryzae attack symptoms on rice grains begin with the formation of several irregular bite marks on the surface of the rice grains. Small holes in the rice grain are made by female insect with their mouth parts before carrying out of the position of eggs on rice grains because all phase of larval and pupal development occur in the rice grain. Cytopilus oryzae attacks can cause severe damage to the grain and will only leave the pericarp of the grains, while the remaining mass of the rice grain will be eaten up. Damage to rice from within the grain is caused by the feeding activity of the larvae inside the affected rice grain.
And then let's do the experiment. Next. The first is tools and materials. The tools and material that we use is scale, plastic glass, rice, and we fill 5 female and 5 male, and then marker, and then notes. Next is work steps. First, we put rice into three plastic cups as much as 15 grams and 100 grams and 115 grams. And then we we put 10 rice refills into each glass. And the next is we observe it and document it every 7 days. Next, the result. The result about amount of rice refills in the first week. And the glaze that contain 15 grams of rice is 6 male and 4 female. And when the glass contain 100 grams of rice, there were 4 male and 6 female. And in the glass contains 115 grams of rice, there were 5 males and 5 females. And the result of the second week, the glass that contained 15 grams of rice, there were 6 male and 4 female. The glass contained 100 grams of rice, there were 4 male and 6 female. And the glass contained 115 grams of rice, there were 5 male and 5 females. Here, second week's rice condition. Based of the observation of rice measuring 15 grams, it was more dominant in color change. On the second week, there is no specific different amount of living rice we leave. The rice condition in the first week of the 15 gram, it's no powder. And the second week is in the 15 gram, it's low powder, and the 100 gram is low powder, and 115 gram is low powder.
Next, amount of rice refill glass contains 50 grams of rice, 101. The male is 48, female 53. Glass contains 100 grams of rice, is 157. Rice refill, male 60 and female 87. Glass contains 150 grams of rice, is 193 rice refill, male 95, for female 98. And the next 8 week, this contains 50 grams of rice, 131 rice refill, for female 71 and male 60. This contains 100 grams of rice, 192 rice refill for male 90 and female 102. Glass contains 150 grams of rice, 230 rice refill for male 105 and female 125. Next, amount of rice refill based on observation, a glass contains 150 grams of rice had the most population of rice bugs compared to other cups. The large population in a glass weighed 150 grams of rice has an impact on the condition of the rice itself. Next, result for 6 weeks based on observation on rice measuring 150 grams. It was dairy inside the glass and more powdery than the others amount. result for 8 weeks based on observation on rice measuring 150 grams. It was more dominant in color change. There's a lot of rice has become powder, and in the glass there is a lot of dew. Next. Discussion based on observation that have been made, it's found that a lot of powder comes from the rice itself. The presence of this rice powder in this set that the rice is damaged due to porous activity by Cytopilus oryzae, which eats rice, and female rice flies, which lay their eggs in the porous rice. The condition of rice containing rice powder can no longer be consumed. The 150 grams glass show the amount of rice powder that is more than the other glass because the 150 grams glass has the high population of Cytopilus oryzae pest. Next. In the glass weighed 150 grams of rice, it was found the glass was dewy and had a much browner rice color than the other glass. This could be due to the large population of rice fields, so that the respiration rate is also high. Respiration activity of Cytopilus oryzae at a high Lea population density can produce a lot of water vapor, so the glass is dewy. Next. Conclusion. Based on the observation we have made, it's now that the amount of feed available can affect the number of Cytopilus oryzae pest population. The more availability of food for insect will increase the population of this insect because insect can survive with abundant food availability. This proves the theory that the availability of sufficient and suitable feed for the live or rice beetle cause the pest population to increase.
So that's all about our final project result. Thank you for your attention and goodbye.